Hi students, welcome to the video lecture 7 on the topic transient heat conduction. So in the today's class we will solve the problems based on the sphere. In the previous two classes we have solved the problems on plane slab and as well as on the cylinder. So today in the class we will solve the problems on the sphere. Let me read the problem first. An apple which can be considered as a sphere of 8 centimeter diameter is initially at a uniform temperature of 25 degrees centigrade. It is put into a freezer at minus 15 degrees centigrade and the heat transfer coefficient between the surface of the apple and the surroundings in the freezer is 15 watt per meter square degree centigrade. If the thermophysical properties of the apple are given to be density 840 kg per meter cube, specific heat Cp is 3.6 kilojoules per kg degree centigrade, thermal conductivity K is 0.513 watt per meter degree centigrade, and this alpha, that is thermal diffusivity, is 1.3 into 10 to the power minus 7 meter square per second. So let us, he has asked us to determine, that is center temperature of the apple after 1 hour, surface temperature of the apple at that time, and amount of heat transferred from the apple. So all the previous problems for slab and cylinder, she has asked us to calculate the center temperature of the apple, surface temperature, and amount of heat transferred. So as usual only we'll solve the problem. So first let us write the given data. That diameter D, he has given it as 8 centimeter, where R is will be 4 centimeter, radius will be. So I have written it here in the meter, it is 0.04 meter. So initial temperature of that apple he has given, this 25 degrees centigrade, and the TA temperature also he has given, it is freezer, it's minus 15 degrees centigrade, and heat transfer coefficient H, that is 15 watt per meter square degree centigrade, is also given in the problem, whereas density has given 840 kg per meter cube and specific heat Cp is, that is 3.6 kilojoules per kg degree centigrade, whereas thermal conductivity K is given as 0.513 watt per meter degree centigrade, and this alpha thermal diffusivity is given as 1.3 into 10 to the power minus 7 meter square per second. So now as usual we will calculate the Biot number. Biot number is given by H into LC divided by K. This characteristic length LC for sphere, it is given by the formula, it is R divided by 3, which we have already explained in the previous classes, in the theory classes. So this R is 0.04 divided by 3, that characteristic length LC will be 0.0133. So this LC value I will substitute in this formula, that is Biot number is given by H into LC divided by K. So H is 15, characteristic length LC is 0.0133 divided by K value, that is 0.513. So if I will calculate this Biot number, my value will be 0.387. So here Biot number is greater than 0.1. When the Biot number is greater than 0.1, then the problem cannot be solved by using lumped system analysis. So such problems are solved by using the Heisler chart. So we'll adopt the Heisler chart solution for such problems. So again one time we are calculating the Biot number when using the Heisler charts. So Biot number here it is given by H into R divided by K. See here. So this LC here it is replaced by R here. H into R divided by K. Rest all other things are same here. Only this characteristic length LC is replaced by R using the Heisler chart solution. So H is 15, R is 0.04 divided by K value is 0.513. So if we calculate this Biot number, so it will be approximately it will be 1.17. So in the graph I require the value of 1 divided by Biot number to read the graphs. So I will calculate this 1 divided by Biot number as 1 divided by 1.17. So this will be 0.854. Similarly, I require the Fourier number also in the graph. So let me calculate this. Fourier number is given by alpha t divided by r square. So alpha is given 1.3 into 10 to the power minus 7. In the data only he has given. So after 1 hour, what will be the center temperature he has asked. So after 1 hour means for 1 hour there will be 3600 seconds, because in 1 hour 60 minutes, so for each minute 60 seconds. So 60 into 60, this will be 3600 seconds divided by r square, where r is 0.04 whole bracket square. So Fourier number value will be 0.292. So based on the availability of these two values, that is 1 divided by Biot number and Fourier number, so we are going to calculate the value of this value from the graph we are going to calculate. So this t minus ta divided by ti minus ta equals to 0.45. So this value I have calculated directly from the graph by using these two values, that is this value and this value. So let me first simplify it and then I will show you how we have got this 0.45 from the graph. So this T, it indicates here center line temperature. So T minus, this is minus, so Ti is minus 15 divided by Ti is 25 minus of minus 15 equal to 0.45. So this will be T plus 15 divided by 25 plus 15 equal to 0.45. So if I will simplify this, my temperature T will be equals to 3 degree centigrade. So now let us move to the next slide. That let me show you how we have got this value as 0.45 from the graph. See here, so this value indicates this indicates here, notations are different here. So this indicates T minus Ta divided by Ti minus Ta. So this value only we are going to calculate directly from the graph here. So you can see here. So in the graph, so on the x-axis, so all these values indicates the Fourier number, all these values indicates the Fourier number, and whereas these inclined lines, these the graphs which indicates the 1 divided by Biot number. So 1 divided by Biot number versus this Fourier number, based on this I am going to calculate this value. So here notations are different, but this indicates T minus Ta divided by Ti minus Ta value. Directly I am going to get this value from the graph. So already we have calculated, that is 1 divided by Biot number as 0.854. So this is the value of 1 divided by Biot number as 0.75. 1 divided by Biot number line is 1. So 0.751 in between here, somewhere here my 1 divided by Biot number, it is 0.85 line will be lying here. So I will draw a straight line like this way with the help of scale till the end of this graph. 0.85 like this way I will draw the line. And on the x-axis, Fourier number already we have calculated it as 0.292. So this is 0.1. So here it is 0, 0.11, 1.5 like this way. So 0.29 will be here. I have marked here. See, 0.29 will be somewhere here. So with the help of scale, so vertical upward line I will draw with the help of scale like this way. So the straight line I will draw here. So where it is Fourier line and where it is 1 divided by Biot number line, where both these lines intersects, so from that point I am moving towards the left horizontally to read the temperature directly on the graph here like this way. So 0.29 Fourier number, the straight line I have drawn with the help of scale like this way, and this is 0.75, 0.1, in between here it will be 0.85. So 1 divided by Biot number graph, that is 0.85, it will be like this way. We'll draw a line here. So where this line and where this line, both lines intersect at one point, from there I am going to move towards the left horizontally to read this temperature. So that we have got it as 0.45 from the graph directly, and we have calculated the value. So our next point is to calculate the surface temperature. See here, at the surface, this R divided by R is equals to 1. This will be fixed. The graph will be fixed for calculating the surface temperature, as well as for cylinder also we are using same formula, and for sphere also we are using same formula, that is small r divided by capital R will be equals to 1. And for plane slab, here we are going to use x divided by L equals to 1. So similar types of graphs are available for a plane slab, for cylinder, as well as for sphere also. Similar types of graphs, but these graphs are different for plane slab, cylinder and sphere. The nature of graphs are same for all the three, that is slab, cylinder and sphere. And in the data handbook, for slab they have given 3 graphs different, for cylinder they have given 3 graphs different, as well as for sphere also they have given 3 graphs different. So here I require 1 divided by Biot number, which is already calculated, that is 0.854. 4. See here, you can observe here, this is R by R, notations are different here. So this is the graph of R divided by R as 0.2. This is the graph of R divided by R as 0.4. R divided by R equal to 0.6. R divided by R equal to 0.8. So this is the graph of R divided by R is equals to 1. So this graph versus this graph. So on the x-axis, the values are plotted as 1 divided by Biot number. So this graph directly I have taken it from the data handbook of Hegde and Niranjan Murthy. Hegde and Niranjan Murthy, this graph. So in the previous problems, I have taken these, copied these graphs from the textbook, that is M. Tirumuleshwar. So for this problem, particularly, I have used the graphs from the data handbook. So 1 divided by Biot number. So 1 divided by Biot number is 0.854. So this is 0 0.01, 0 0.05, 0.2, 1, 2, 3, like this way. So here it is 0.2. Let me see here 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, like this way here. So 0.8. So this graph, this is the 1 divided by Biot number. So 1 divided by Biot number 0.8. So I will move straight away like this way. So where it will intersect the graph of 1, up to that point I will move here. So this graph at 1, somewhere it intersects near 0.6. So from here the straight away I will move towards left horizontally. So my value will be, it is 0.6 from the graph. See here. So this is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So 0.85. So somewhere it will be here nearer between 0.85 and 0.9. So here I will move straight away, and where this graph intersects, that is R by R, from there I will move vertically, horizontally towards the left side. So if I want, I can show you by taking the pointer of pen. See here. You cannot change it now. So here you can observe here, already we have moved here, so this will be 0.6 from the graph. So this is the surface temperature. This temperature, see here, same formula here. Again, the only notations are different. So T minus TA divided by Ti minus Ta in the previous formula. So this Ti is replaced by T naught here. See here in the graph also they have given T naught. So T naught indicates centerline temperature. Here I have to substitute the centerline temperature when calculating the surface temperature. So this T here, it becomes the value to calculate the surface temperature, and this T here, it acts as the centerline temperature. So while calculating the centerline temperature, so this T indicates the centerline temperature and this T indicates the uniform temperature of the sphere. So here while calculating the surface temperature, so this T, it indicates the surface temperature, and this T, it indicates the centerline temperature. So T minus of minus 15. So 3 already we have calculated centerline temperature as 3, minus of minus 15. So from graph already we have read this value, this is 0.6. So T plus 15 divided by 18 equal to 0.6. So if I will solve this value, I am going to get the value of temperature T as minus 4.2 degree centigrade. So now last one, amount of heat transferred from the apple he has asked. So we have to calculate the value of Q. We have to calculate the value of Q. So this Q divided by Q maximum, this value I have calculated this as 0.62 from the graph. So there may be some error in reading the graphs. So minor errors are okay while reading the readings. So Q divided by Q maximum equals to 0.62. This value directly I have taken it from the graph. So in the next slide, I will show you the graph and how I have got this value. So therefore Q is calculated by the formula Q maximum into this. Q is equals to Q maximum into this 0.62. So let me first explain you how to calculate this value. So on the graph, so again on the x-axis Biot number square into Fourier number values are plotted, and inside the graph they have plotted the values of Biot number. So Biot number square, this is 1.17 whole bracket square into Fourier number is 0.292. So Biot number square into Fourier number we have calculated it as 0.399, which will be equals to 0.4. So Biot number is 1.17, which is already calculated. So with these two values I have calculated this q divided by q maximum as 0.62. So where q is given by q maximum into 0.62. So now q maximum is given by the formula m into cp into delta t. Delta t is nothing but m into cp. Delta t is nothing but ti minus ta, that is maximum possible heat transfer. So m is replaced by density into volume, Cp as it is Ti minus Ta. So this rho is 8840, already it is given in the problem, whereas volume of the sphere is calculated by the formula 4 upon 3 pi r cube. 4 upon 3 pi r cube. 4 upon 3 pi I have kept as it is r cube is, where r is 0.04 cube into this Cp they have given in terms of kilojoules, so I have converted this value in joules, 3.6 into 10 to the power 3. So Ti is 25 minus of Ta is minus 15 degrees centigrade. So if I will solve this entire, I am going to get this Q maximum as 32,427 joules. So Q maximum I have got this value 32,427. So now Q is equals to Q maximum into 0.62. So if this Q maximum is multiplied by this 0.62, I am going to get the value of Q as 20,104.74 joules. So now how I have got this value from the graph? So let me tell you here. See, this graph is also taken from the data handbook only, because they have clearly mentioned, they have drawn the lines in the data handbook here like this way. But in the textbook they have not drawn these vertical lines. So from the data handbook this graph can be clearly seen here. So now Biot number square, that will be 0.4. So here you can see here these are the values on the x-axis which indicates the Biot number. Biot number square into disto indicates Fourier number. So here this is 0.1. I can write it as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So somewhere it will be here 0.1, 0.2, 0.3, 0.4, 0.5 here. So my reading it is Biot number square into Fourier number is 0.4, 0.1, 0.1, 0.2, 0.3, 0.4. I will mark this line here. So my Biot number value is 1.17. So this is the graph of 2, this is the graph of 1. So this is the graph of 1. So this is the graph of 50, Biot number 20, 10, 5, 2, 1. So my value Biot number is 1.17. So I have to concentrate on this graph. So this is 0.1, 0.2, 0.3, 0.4. So from 0.4 I will move vertically upwards till it intersects the Biot number curve. So this Biot number curve is somewhere intersecting here, that is Biot number curve 1, that is 1.1 somewhere here. So from here intersection point, so I will move horizontally towards the left from intersection point to read this temperature, that is Q divided by Q maximum. So it will be around 0.62. I think, hope you have understood this graph how we are calculating is. So Biot's number square into Fourier number is 0.4. So I have moved vertically, this is 0.1, 0.2, 0.3, 0.1, 0.2, 0.3, 0.4. So from here I have moved vertically upwards till it intersects the curve of 1, that is Biot number 1.1. So from here I have moved horizontally towards the left, so it will be around 0.62 from the graph. So how we have calculated the value Q divided by Q maximum as 0.62.